So what we're looking at today are ways to organize the information that you're given to make it easier to calculate the probability. Okay? Both of these you have looked at before. You've seen Venn diagrams. You've done these things. Okay? May have been a while, but you've seen them. Contingency tables, we've used those in here before. The thing is, normally you've been provided with these and you just have to answer the questions. Now you're going to have to figure out how to put one together and then answer the questions. Okay? So we're going to look at just reading them first, and then we'll look at how to create one. So on Venn diagrams, we're going to have each circle labeled with what it represents, and then the numbers in the overlapping parts are in those categories where it's contained. So if we're looking down here at how many students were interviewed, we're just going to add up each of these numbers that are inside the circle. So you would just add all of those numbers together, and we would get 86. So if we want to know, part B, how many students like rock music, we're going to look over here at this circle, and we're going to add up all the numbers that are inside the circle. So you would do 18 plus 11 plus 7 plus 8. And we would get 44. So it's always a good idea to write down how did you come up with this number. So show your work on how you got that number, just to make sure that it's evident. Then part C, how many students like rap or country? So now we're looking at anything in this circle and anything in this circle. So basically we're not counting 18. It's everything else. Okay? So we can add all of these together, or we can say, well, it's all of this 86 except for the 18. So I can just do the 86 minus 18. Because those 18 are the only ones that didn't like one or the other of the categories. So 68 students. Now part D says how many students like 2 out of the 3 types. So we see the ones in here are the ones that like multiple types. These 7 like all 3 types. These people out here like 2 out of the 3. That's the ones we're looking at. We're adding together this 8 plus 1 plus 11. So we get 20 students. And then the number of students that like all 3, that's going to be where all 3 circles overlap, so that's going to be the 7 here in the middle. And then how many students like one type only? So that's going to be the numbers out here where the circles do not overlap. So the 18 plus 24 plus 17. We have 59 students. Like only one type of music. Seem okay? You guys remember doing these before? May have been a few years. But you've probably done them. Over here on this other side, contingency tables, we did these earlier this year. Was the probability that a person was satisfied with the services, so we look at the satisfied and the total there over the total number of people. So 800 over 1,000. So anytime you're doing a probability, they want to see this fraction, whether it's just using the raw numbers here or a reduced form or whatever. You can leave it just like that and you're done. Don't have to simplify it, don't have to make it a decimal. If you do either of those, that's fine, but you don't have to. So when you're taking, especially like on the AP test, where it's a time test, don't take time to simplify things that you don't have to. Just leave it. On part B, What is the probability that a person was male or not satisfied with the services? So the male is here, and then not satisfied. We also have these females over here that were not satisfied. So we're going to add together all of the people who were either male or not satisfied. So we're going to add together the 384 plus 80 plus 120. Then we add together the males and the not satisfied. Well, because that's our total number down here. Yeah. Part C, what's the probability that a respondent was female? So our total female is 536 out of the 1,000. So down here on part D, it says, what is the probability that a respondent was female who was satisfied with the services? So we're looking at female and satisfied. There's 416 of those out of the total number of respondents. And the last one, if a respondent was satisfied with the services, what is the chance they were female? Now this one's a little different than the other ones. We're looking at only those who were satisfied with the service and finding out what's the probability that in that group we have a female. So we're looking at the satisfied and taking how many females out of this 800. So we're doing 416 out of 800. So you have to really watch the wording to see what is the group that is being considered and who are we looking for in that group. So here we're only considering those that were satisfied with the services to find the number of females. Questions on that? Okay, well, let's look inside. So here they give us a setup for the Venn diagram, but we need to fill in the numbers. So this one says, as 400 college students walk by a campus interviewer, we learn that 120 are enrolled in math, 220 are enrolled in English, and 55 are enrolled in both. So we're going to use this information to fill in the Venn diagram. So we have two different options of classes. We have math and we have English. When you start to fill one of these in, always start with the center part, with the overlapping part, because that will help you distinguish how much is on the outsides here. So here we have 55 are enrolled in both. So that's where I'm going to start, is with that 55 in the center. Then I notice over here, 120 are enrolled in math. That means this entire circle over here needs to equal 120. Well, I already have 55 of that, so I need to subtract these numbers to see what goes out here. So if I do 120 minus 55, I get 65 for the math only. Okay, so this total circle equals the total in math. Then I do the same thing with the English. 220 are enrolled in English, so I need this entire circle to equal 220. So if I already have 55, that leaves 165 for out here. Are we okay with how that? Yes. Right, because some people are not enrolled in either course. Yeah. What does it add up to? We'll write it down. I think, if I remember right, there's 115 left over, I think. Yeah. So 115 of these 400 students were not enrolled in English or math. I agree. Everyone should be enrolled in math. So, are we okay on filling this in? Okay. So here they're asking, what is the probability a student is enrolled in mathematics? So we have 120 out of those 400 students are enrolled in math. That's our probability, is 120 out of 400. So if we want enrolled in math or English, we're going to add all of these together, which we already found was 285. So we already got that for us. The student is enrolled in either math or English, but not both. So that's where I'm going to add these two numbers together, because I don't want the people that are in both. I'm going to exclude this 55 and just do these two. So I'm going to do 65 plus 165 out of 400. Okay, we're good with that one, the first example? Okay, number 2 says, a survey of 100 married couples taken by calling every 50th person in the voter rolls found that the husband is employed in 85 of the couples, the wife is employed in 60 of the couples, and the spouses were both employed in 55 of the couples. So, I want to know how many is the husband employed, and then the wife is employed. So when I start filling in numbers, I always start with the both. Both is 55. So that's going to go in the center. So now I can look back and see the husband was employed in 85, so these two numbers need to add to 85. So 55 is in the middle, that leaves 30 out here. And then the wife was employed in 60, so if that's 55, there were only 5 where the wife was employed but the husband was not. So at least one is employed, we'll add those up. So we get 90 out of 100. So that means if this is 90, there are 10 where neither is employed. So this will be, and you can show this as 1 minus 90 over 100 equals 10 over 100, or you could just say 10 over 100 because that's what's out here. If you write it out here, then you can just do this. But if you don't, you need to show how you got it. Okay, so far feeling good? This is when it gets tricky. When they get 3 circles overlapping. These are the ones that people get really caught up with. So, when you're filling one of these in, always start, like we started up here, starting in the overlap, you want to start here in the very middle. Start with that one. So here, 6 like all 3. That's where I'm going to start, is right there. The different groups I'm looking at are math, science, and social studies, so I'm going to label those circles. Then I'm just going to go into each of the overlapping areas here. So I'm going to start at the bottom here. 12 like math and social studies. So this math and social studies, this part right here where those overlap, should add up to 12. So if I already have 6 here, this part needs to be 6. So this total overlap for math and social studies is 12. That's 12. Then we go up to the next one. 10 like social studies and science. So we're looking at this overlap right here should add up to 10. So we already have 6 in the middle, so that means there's a 4 out there. Then for math and science, so this part up here, we need a total of 18. So if 6 is here, we need 12. And then top there. Then we can go to finding this part outside. So if you're looking at the social studies circle, the total circle should be 34. So here I have 16. I need to get to 34. So that leaves me 18 more. So that this entire circle is 34. When I go to science, this circle should equal 43. So here I have 22, so I need another 21. And then math, of course, is the favorite, because it is. So we have 24 already accounted for out of the 57, so I need another 33. So you can see, if you start in the center and work your way out, it's a lot easier to figure out where the numbers go. Okay, so let's look at a contingency table. For number 4, we have Amber, who's a college senior, and she's interviewing with 2 different companies, Acme Corp and Mills Inc. She has a 35% chance of receiving an offer from Acme and a 48% chance of receiving an offer from Mills. There's a 15% chance she will be offered both jobs. So we need to fill this into this table. So when I'm doing a table, I look at what are the decisions that need to be made. Either Acme will offer her a job or not, and Mills will offer her a job or not. Okay? So I'm going to put the Acme up here, and then Mills along this side. And then for each one, there's either a job offer or no offer. So I'm going to say so then we need to fill in our values. Anytime you're given percent, I usually do like a total of 100. That way I just write the percent. 35% is 35. 42% is 42. So it makes it a lot easier to come up with the numbers in here. So it says she has a 35% chance of receiving a job from Acme. So the Acme, the job offer, that total is 35. So that's the total chance of getting this offer. She has a 48% chance of an offer from Mills. So the Mills offer, 48. There's a 15% chance she will be offered both jobs. So a job offer here and a job offer here. That goes right in that square. So 15 right in here. So to fill in the other numbers, this row should add up to 48, this column should add up to 35. So this should be a 20, and this should be a 33. And then we'll do the same thing over here on the total column. We need 48 plus something to equal 100. So that something needs to be 52. And then along the bottom total, 35 plus something equals 100. So that needs to be a 65. And then you can use either one to get this last. So these two add up to 52 or these add up to 65. So either way you get 32. Are you okay with filling in the table? Once you get that done, answering the questions are not too bad. It's just filling in that table can sometimes be confusing. Okay, so this says, what is the probability that Amber receives a job offer from only one of the companies? So this means she gets a job offer here, but not here. So there's 20 of those. And then she gets a job offer here, but not here. So 33. So we're adding together these two numbers. 20 plus 33 out of 100. And part B says, what is the probability Amber does not receive a job offer at all? So that would be no offer from both. So there's 32 out of 100. And then what is the probability of at least one company offers her a job? So you can do this a couple of ways. We can add together these numbers, because those are all the ones where she got an offer. Or we could just do 100 minus this 32, because this is the only time she didn't get an offer. Okay? So it's whichever way makes more sense to you. So you could do 1 minus the 32 over 100 that we just calculated up here. Because that's the only time she doesn't get at least one offer. So we can subtract to get this 68 out of 100. We're doing okay? Those are not asking questions. I hope that means that you understand, not that you're asleep. Something's happening. Okay, let's look at number 5. So here we have a store that sells 2 brands of a particular item. 60% of the items come from supplier A and the rest from supplier B. Of the items from supplier A, 5% are defective. Of the items from supplier B, 10% are defective. So we need to fill in this table with that information. So we're talking about 2 different things. Which supplier did it come from, and is it defective? Okay, so that's going to be what we set up on each one of these. One of them is going to be, is it defective? I'm going to put that at the top. So that'll be either yes or no, it is or it isn't. And then over here, I'm going to write my supplier. And that's either going to be supplier A or supplier B. Sometimes just getting to this point is the most difficult part. So seeing why I picked those things to label it, you just look at what are the options, what do I have options about, put one at the top, one on the side. Okay, so now we need to fill in some numbers. It says 60% of the items come from supplier A. So for A, the total is 60%. Since we're dealing with percent, our total is going to be 100. Then the rest from supplier B. So that means 40% is here. Now this one gives us the defective rate in a little bit different terms, because it says of the items from A. So of the 60, 5% of the 60 are defective. So we can't just put a 5 here, because it's not 5% of the 100, it's 5% of 60. So you have to do 60 times 0.05 to get that 5%. So that's going to be 3. So 3 out of the 60 items is defective from that company. So that means 57 of them are not defective. Of the items from supplier B, 10% are defective. So we get 40 from there. If 10% of the 40 are defective, that's 4. So that means 36 are not defective. Then we'll just add up our columns to get the totals at the bottom. Okay, so the first question wants us to know, what is the probability of receiving a defective item? Well, the defectives, there are 7 total out of the 100. So that's our probability, is 7 out of 100. And B says if it is defective. So if we know it's in this column, what's the probability it came from B? So we look at 4 out of 7. C says if the item is not defective. So now we're looking at this group. What is the probability it came from A? So the A is 57 out of the 93. Okay, so that notes page is going on page 113. Attach it, don't just stick it in there. You've got tape on your table, glue on your table. Use it.
You have another roll of tape.
The what?
Another roll of tape for out.
Yes.
Thank you.
Once you get that attached, then your problem set 33 is going to go on page 114. So you guys have plenty of time. You should be able to finish that and not have any homework.